it's like this, and the question is, what's Km? So Km is Vmax, so you go to the maximum velocity, V is like rate, over 2. So if we know this, Km is equal to Vmax over 2. So in this case, let's say this is like 2, 4, 6, 8, 10, 12 or something like that. Vmax over 2 would be 12, 6, right? So then we go 6, and that is right here. So Km is a substrate. It will be a substrate value, which means, I don't know, say it's like 0.1, 0.2, etc. So that means Km is equal to 0.1 in this case, whatever units it would be. So then, let's say, yeah, that's just how to find Km. If they say sometimes questions are like, what is the significance of Km? So let's imagine we had a competitive inhibitor. So competitive inhibitor graph would look like this. It would still reach the same Vmax at a point, because at high substrate concentrations, high substrate outcompetes the competitive inhibitor for the active site, right? So Vmax is still going to be 12. Still Vmax is 12. But Vmax over 2 is still going to be 6. Okay? But when we go along from 6, Km is going to be 0.2. So Km with this competitive inhibitor is 0.2. So we can see that Km has increased. So that means that basically the mark-scheme point is, as Km increases, affinity of enzyme for substrate decreases. Like, it's an inverse relationship between Km and affinity of enzyme for substrate. Alright, so then, and we can kind of see that because a really low Km, like imagine a graph that, you know, the enzyme loves the substrate so much, it's like this, like you reach the max so quickly, that Km, it's going to be tiny, it's going to be here. So that really low Km shows that really high affinity of that pink line, right? And then a really high Km, like it hates the substrate so much, it's purple, it's like, oh, it's so slow to get with that substrate. We're gonna still have Vmax 12, we're still gonna have Vmax over 2 is 6, but when we go across from that 6, we have some crazy high Km at 0.3 here. So the lower the affinity of the enzyme for the substrate, the higher Km gets. Now competitive inhibitors, they all finish at the same spot, because this is your enzyme, this is your substrate, and this, okay, dodgy shape, my bad. Okay, this is your substrate that fits inside there, and let's say this is your competitive inhibitor. So the competitive inhibitor and the substrate both want this. This is substrate. So, and then, but as the concentration of the substrate gets higher and higher, it eventually outcompetes all of these, which is why we can reach that Vmax. A non-competitive inhibitor binds on somewhere here in an allosteric site, non-competitive. This is non-com. So that changes the shape of this, which means these can no longer bind. Changes non-competitive inhibitors change the shape of the active site. So it will never achieve Vmax because it's not about the enzyme's affinity for the substrate, it's just about changing the active site shape. So a non-competitive inhibitor, do orange, will look like this. Okay, it will never achieve Vmax. And the thing to note is that Km of non-competitive inhibition remains unchanged because the enzyme's affinity for the substrate is not changed by adding a non-competitive inhibitor. It still wants the substrate just as badly, but it's just been non-competitively inhibited, so it can't get to it, right? So yeah, that's basically pretty chill, right? Vmax over 2 and Km is a substrate value on this x-axis, Km is on the x-axis. That's like basically it. Cheers.